Let's learn sliding window technique. This is a really powerful tool that is used in computational, and this is a very popular coding pattern that has been asked in probably like hundreds of interview, thousands or if not hundreds of thousands of time. So this is a really important to learn. This can improve your code and your coding efficiency significantly, and also helps you reach to the optimal solution in the fastest manner. Now question is, what is sliding window? Before we go into the technical aspect of it, let's try to understand a real life example. Suppose we are given a chain. Now this is an iron chain and we found out that this iron chain is currently rusting. One way to solve this issue is to use paint on our iron chain. So if we want to paint the iron chain, what are some of the options we have? Well, let's first consider one very inefficient approach, and that is to lay the entire chain flat on a table, and then we start pouring our paint from top on all aspects of the chain. What would happen is that eventually our chain would get converted into the paint, this paint blue, and we would have our chain like this is successful, this is what we wanted. But in the process we would have spilled out a lot of paint on the table as well, and that is not what we want. So what is one better approach to do it? And you must be thinking that, hey, this is pretty simple. We can just use a simple brush, and on top of the brush we can use our paint, and then using our brush we would start painting the portions of the chain one at a time. Then again we would replenish our brush, and then we would keep on repeating the same process until our entire chain is covered with the paint. In this example, what we did is that we took a certain window, in this case a brush, and that size of the window we applied to our input, which is our chain, and then we were able to accomplish our task. Then again we repeated the same process for the next set of window, and again we repeated the process for the next set of window. This is the whole meat of the sliding window technique, where we take a smaller bunch, we apply some computation to that, and then we keep on repeating the same process for the entirety of the input. And congratulations, you just learned the sliding window technique. There is nothing more than that. But there are few technical aspects, and you have to identify in an interview that when to use it and what are the scenarios that you need to consider, because your interviewer is not going to say that, hey, this is the array problem and solve it using sliding window technique. He is just going to say that this is the problem, what should be the approach that would come to your mind. So in that scenario, one approach I always consider is that to identify when to use sliding window. Well, one most common thing we understood is that the input size remains fixed. There is no changing in the continuously enlarging input size, which means we have a fixed set of input where we need to do some computation using our paint or our window in this case. So the idea is that typically this is a very good candidate for array or a linked list kind of a problem, and even sometimes for the strings we can apply the sliding window logic. How in the strings? Because remember, string is also a set of characters that are just bunched up together, and that forms a string. So again, for all of these three things, whenever you encounter any problem, you can try to see if it can be solved using sliding window. Now let's just go through the practical aspect of sliding window. What are some of the possibilities we can have in a sliding window problem? First possibility is that suppose we are given an input that is of length 7 currently, okay, and for this one way we can use sliding window is we create a window of size k. So in this case, let's say for an example our k is equal to 2 and the window is of size 2. Then we do some computation in this part, then we incrementally keep on going for the next element. So in this case, since we already took care of this window, now we are going to move on to the next window where we are not considering this element number 0. So for the next window we are going to go for these two values. For the subsequent window we are going to go with these two values, and we keep on repeating this process until we reach to the end of our computational input. And this is how we would be asked to calculate some value inside our input and then come up with the answer. Okay, this is one way sliding window can be used. You will need to use two pointers that will keep track of the starting and ending portion of our sliding window. And this is going to be the key portion in any sliding window problem. Whenever you can see that the problem can be solved using 2 pointers, then 2 pointer is very closely allied with the sliding window concept. 2 pointer is like Walter White, and sliding window is like Jesse Pinkman. Okay, so that makes things more understandable. Now let's just try to see one example where we will try to solve our problem, and I'll be showing you both the ways. I'll be showing you the brute force way, and then I will be showing you that how using sliding window we can improve upon in our given answer. So suppose this is the input we are given. We need to find a pair of 2 consecutive elements that sums the maximum. So what is the simplest way to solve this problem? If we try to think about the brute force approach, well, the simplest way to solve this problem is to make every single possible pair, and then try to do sum of that pair, and try to find the answer for that. So that is like pretty simple approach, and we can consider that how it would work. What we would do basically is that first we would take this window. Okay, so this one, the sum currently for this one is 19. Then again we would take this next window, and the current sum is going to be 21, and then we would take this window, and the sum is going to be 18, and so on and so forth. Every single time we would be able to do this, and we would be able to find the solution. Now in order to generate the solution, what happened is that for every single value we need to iterate over all the k values inside our given array, because currently we are being asked to give us the pair of consecutive elements, so 2 consecutive back-to-back elements. In this case, the time complexity is going to be that we will have to iterate over every single element at once, so big O of n multiply by big k. So in this case, since k is equal to 2, it is going to be big O of 2k. So this is going to be the time complexity for our problem if we use the brute force approach, because for every single time we will have to create a new pair, do its sum, and then get that value considered. In the next approach, the idea is that rather than this, if we use a sliding window, our lives would be much more easier, and we would be able to solve this problem in big O of n time only rather than big O of kn. And let me show you how. The idea is that first of all we are going to create 2 pointers, and for these 2 pointers we are going to have a starting value and an ending value that is true. So first time the starting value is going to be at the first position, so value number 0, and our ending value is going to be at value number 1. Okay, now what we are going to do is we are going to do the sum of these 2 values. So currently the sum of window is going to be 19. Okay, we are at the same time also going to have a max variable where we are going to keep track of that what is the maximum sum we have found so far. So initially this max value is going to be like the lowest value possible, and if we encounter that for any given sliding window the sum is greater than what we have, we would add that value to our maximum variable. So in this case currently the maximum window sum we have found is 19. Okay, now we need to check other sliding windows. So what we are going to do is we are going to do like start plus plus and end plus plus. So our starting and ending pointer is going to be updated. So now this is going to be our new starting and new ending pointer. So again the value is 18 and 3, but this time we do not need to calculate the sum of both of these value to generate our sum. What we can simply do is we can take the previous sliding window that we have calculated, and then what we did is we got rid of this element and we added this element. So this is simply we can apply to our sliding window as well, where from our existing sliding window 19, what we can do is we can get rid of value number 1, so the previous starting value, and we can add the new ending value, so plus 3. And if we do this, we will basically get our maximum sum to be 21. And in this case, since 21 is definitely greater than our input, our max sum, so we will get rid of this one and we will add the maximum sliding window sum we have found so far is 21, and currently the sliding window sum at this moment is also 21. Again, if we repeat the same process and we get rid of this 18 and we include this 15, then again we need to do 21 minus 18 plus 15, so that would give us the sum of value number 18. Now currently you would find that since I'm only considering 2 elements, this would not look much of an improvement. Why? Because you can clearly argue that hey, it's pretty easy to calculate sum of 2 values inside any window. but intentionally I chose the initial window or to be of size 2, because say for an example, rather than the input being of size 2, or we need to find consecutive pair of elements. Say for an example, this input is comprised of almost 100 elements, okay, and at the same time we need to return the 4 or let's say 10 consecutive elements that provide the maximum sum. In this case, sliding window approach is going to be a humongous improvement. Why? Because for the first time you would calculate the sum of the first 10 elements, and then every single time you will need to calculate the sum of the next sliding window. You will not need to do the entire computation of all the 10 elements. You can simply apply this formula where you would get rid of the first element that is no longer be the part of the consecutive sliding window, and then you can only add the next element, and that would be pretty significant improvement in your code. So this is what any employer or any interviewer is going to need to check, and this is the whole core logic behind sliding window technique. Now let me give you a very quick example of an actual real life LeetCode problem that has been asked in probably, I don't know, tens or hundreds of companies, and we'll see that how we are able to improve upon the solution using sliding window. Okay, so as an example, we are trying to solve the contains duplicate 2 problem. Now this is a very popular LeetCode problem that has been asked in some of the popular companies like Amazon, Facebook, Adobe, Microsoft, Uber, Google, Bloomberg, Airbnb, and Plenty. So these are all tech giant companies who love asking this question, so that is why I considered this one. Let's try to see the problem statement. The problem statement is actually quite simple, and this is a LeetCode easy problem and also a very well-liked problem on LeetCode. Basically, we are given an integer array called nums, or we are going to denote it as n, that contains array values. We are also given a value k, and k can be anything like 1, 2, 3, 4, any single integer value. So suppose k is equal to 3. Now we need to return true if there are two possibilities. The first possibility is there exist any two values I and j that are exactly same. So if there exist two duplicate values in the array, and the second portion is that the difference between I and j, so I and j refers to the index positions of every single value inside the given array. So the index position should be actually less than the value of k. Let's try to understand this with few examples. So suppose our given input n is equal to 1, 2, 3, 1, 5. If this is the input we are given, and we are given the k value to be 4. If this is the case, does it satisfies these two properties? So first let's see. Okay, so we need to check that between the window 4 there needs to be two duplicate values. Currently we can see that there exists a duplicate value 1 and 1 over here. Let's see the index position, 0 and 3. So if we do the difference 0 minus 3, so basically we need to do the absolute difference. So the answer is going to be 3. 3 is actually less than the value of 4, which means this one currently contains the duplicate value that is not far away from 4 elements from each other. So in this case we are going to return true. Let's try to understand it with one more example. Suppose our given n is equal to 1, 2, 3, 1, 0, something like this, and our given k value is equal to 2. If this is the case, again same scenario, we have the values located at index position 0 and index position 3 that contains the same value, but current k value is equal to 2. And if we do the difference between these two values, the current difference between indices is 3. Meanwhile, our given k is equal to 2, which means in this case we need to return false, because there does not exist any two duplicated values that are two steps away from each other or between two elements of each other. So this is the whole ask. Now let's see that what is going to be the simplest approach we can take. Okay, so suppose this is the input we are given. Now let's see the brute force way to solve this problem, that we pick any element, then we check the next k elements. So in this case, currently we are allowed to check up until this point. So between these portions, we check that whether 0 is present in any other value or not. If 0 is not present, we can define that 0 would not be a duplicated entry in any of the window, because we are strictly told that we can only check next 3 elements. So in this case, we can get rid of 0 because 0 is not present. Same way, we are going to check for value number 5. So currently value number 5 is located at index number 1, which means we have the ability to compare between these portions. So again, for value number 5, we are going to check this value, and this value, and bingo, we find value number 5, so we can return true in this case because element number 5 exists and the difference is less than 3. But this is like a very inefficient approach. Why inefficient approach? Say for an example, this entry does not contain any duplicated values and all the values are unique, and at the same time what we would do is, for every single element we would compare it with the next 3 elements and we would keep on repeating the same process until we reach to the end of our loop, and that would be an inefficient approach because the time complexity would be big O of n. So n is the total number of elements multiplied by k, and this is not what we want. We want something more efficient. So let's see a more efficient and better approach. A better approach is that we know that for any single value we need to check in the remaining portion whether that value is present or not. So currently we can break it down in this sequence. So currently we can create a window like this, 0 and then 5 2 7. Currently we are at this position number 0. Now we need to check that whether 0 exists in the remaining 3 entries or not. First approach is to do binary search. So for binary search, what we would need to do is we would need to sort this given input, and if we sort this input array, the sorted result is going to look like this: 0 2 5 and 7. And then all we need to do is check any 2 consecutive values. If we identify that there exists like a back-to-back entries that contains the same value, then we can return true. If it does not contain, then we can move on to the next window. And again, in the same way, we would repeat the same process for this next window that is currently comprised of the values 5 2 7 and 3. And again, okay, so let me fix this one. So this one should be 5 not 7, and 5 2 5 3. So again, if we sort this window in this case, the answer we are going to get is 2 3 5 5, and we found 2 back-to-back values that contains the same value. So in this case we can return true. But the thing is, even this approach is also not very efficient because if we see time complexity in this case, the time complexity is going to be big O of n then log of k. Why log of k? Because for any given input we will actually have to sort this, and sorting it cost us a lot of time and energy. And this is better than the brute force approach, but still there can be improvements made. So what is one improvement we can make? And again, remember, we are using sliding window because we know that we need to do this in any subsequent values and we need to find the answer. So definitely you understand by seeing the problem that why we need to use the sliding window. But let's see that what would be the improvement we can make. First thing we need to check is that in the binary search approach, what we had to do is we need to check that whether in the remaining portion does the same element exist or not. And also at the same time, we were considering that every single time we need to create a new window, we would have to do the entire sorting calculation again. So we need a data structure that can very quickly like get rid of elements and add new elements, at the same time very quickly search that whether the existing element exists or not. And the wonderful answer for this this type of scenario is a hash map. So we can create like a hash map or a hash set inside our input, and hash map and hash set are wonderful at doing 2 things, like doing the search and remove and input operations in big O of one time. So hashing is really good in that. Also at the same time, it does not allow duplicate entries, so no duplication is allowed, which means we can identify duplicate entries very quickly, very efficiently in any sort of hashing input. So we are going to use this property combined with sliding window approach to solve this problem in the most efficient manner. Let me quickly show you. So first we are given the value of k, which means we are going to create our window. So currently let's just create a window of size k. Okay, so starting from value number 0 to value number 5, and then we will have all the values 0 5 2 and okay, let me just put down some different value over here, and let me put 5 over here. Okay, and then this is going to be 4. Okay, so this is these are the current values at the moment. We are going to initialize a hash map. Now inside this hash map we are going to store 2 items. We are going to store the value as the key, and we are going to store the indices based on its value inside the hash map. So first we are going to check, okay, this one is value number 0. and currently the index values are 0, 1, 2, 3. So 0 is not present in the hash map. We will add entry 0 over here and its index value 0 as well. Again 5 is also not present, so we will add entry 5 over here and its index value 1 over here. 2 is also not present, so 2 and 2. And again 4 is not present, so 4 and the index value is 3. So we add these 4 entries in our hash map. At the same time, we can check that currently, since the value of k is equal to 3, we already added 4 elements and still we were not able to find any duplicate entries, which means we will have to update our window. So in order to update our window, rather than getting rid of all the items, what we can do is we can just get rid of the first element, and then we can just shift our window to include one more entry inside our input, and that is going to be value number 5 for the index value position number 4. So again we add 5 over here. At the same time, since we got rid of the first index value, we are going to also get rid of that inside our hash map. So we are going to get rid of the first entry, and currently we have 3 entries. Again we will try to check that whether 5 exists or not. So we will try to input 5 inside our hash map, but we would be able to immediately find that 5 is already present as a value inside our hash map, and immediately we can return true, saying that this contains duplicate inside a k window. And see, what we did is that initially our window was consisting of this value number 0. We got rid of the only 0th value, we kept the remaining values inside our window, and we simply added a new value inside our hash map. And then we were able to immediately identify that whether this is the correct response or not. And say for an example, if somehow this value is not value number 5, this is value number 11 or something else, this does not contain any duplicate entries, what would happen is that every single time we would get rid of the last element from our hash map, and we would keep on adding new values to our window, and eventually we would reach to the end of our input, and if we don't find any answer, we can simply return false in this case. So if we see time complexity in this scenario, the time complexity is actually going to be big O of n only. And since for this case we had to use a hash map of size k, the space complexity is going to be big O of k. But this is a very wonderful and beautiful approach to solve this problem. So that is why the sliding window technique is really powerful, because you are already building your solution upon the already calculated computed values. You are not doing everything from scratch, and that is very powerful in making your inputs more efficient. Okay, so for this problem, I'm not going to write the entire code. I'm just going to give you the explanation. So first we are going to initialize our hash set, and I mentioned that we can use hash map or hash set, anything. In this case, we are using hash set. Now we are going to iterate over the given input array using a for loop. First thing we are going to do is to check that whether our set contains the current value, current ith position of value we are at. If that is the case, we can return true immediately. If that is not the case, we would add that entry to our hash set. At the same time, we would check that if the current size of hash set, if that is greater than our given input k, if that is the case, then we need to remove the earliest entry inside our hash map, and we can calculate that using the number of ith index that we are currently at minus the value k. And then if we remove that value from the hash set, our hash set is only going to contain only the k elements, and then we can keep on repeating the same process until the very end. If we haven't returned true by then, we can return false in the end, and this is going to be the whole solution. Let's try to run this code. Seems like our solution is working as expected. Let's submit this code. And our code runs decently efficiently compared to a lot of other solutions, and I would be posting this in the comments, so you can check it out from there. Thank you.